Welcome! I am Teacher M. This tutorial video is focused on definition of derivative. If you are interested, stay and watch the entire video. To understand better the derivative, let's start to review the basic concept of a line. How to find the slope of a line? Pause for a moment and think and try to remember how to find the slope of a line. The fundamental process is to select any 2 points on the line. Let's use these 2 points to illustrate the slope. To find the slope, get the ratio of change in y and change in x. To visualize, this is the change in y and change in x between 2 points on the graph. To explain further, we usually use rise over run to get the slope of a line. The rise is the change in y and the run is the change in x. To make this concept concrete, find the slope of the given line. Pause for a moment and try to get the slope of a line. To continue, the change in y is 4 units. From here, count 1, 2, 3, and 4. The change in x is 2 units. From here, 1 and 2. Get the ratio, which is 2. Observe that if you pick another 2 points on the line, you can get the same result. To try this, pause the video and select another points and get the slope of a line. This is the reason why the line has a constant slope. How about how to get the slope of a curve? Pause for a moment and think the slope of the given curve. Given the situation, how do we get the slope of a curve? To address this, let's look at this way. The slope of a curve is determined by a tangent line to a specific point on it. For instance, given a point on the curve, draw a tangent line to it. Then, get the slope of a line. Using GeoGebra, we can easily find it. The slope of a tangent line and the given point is 2. Our focus is not on how to use the GeoGebra on finding the slope of a tangent line, but to understand the whole concept of it. Going back, the slope of the tangent line to a point on the curve is the slope of the curve at a given point. Thus, the slope of the given curve at the point is also 2. Observe when we move the point on the curve, what will happen to the slope of the tangent line? Pause for a while and observe the graph. As you can see, the slope of the tangent line changes at every point on the curve. This leads to the conclusion that the slope of a curve is varying depending on each point on the curve. In comparison to the line, we established a while ago that the slope of a line has a constant slope. But the slope of a curve is changing at every point. The great question is there a way to get the slope of a curve at a specific point on it? We cannot use the tangent line alone to find the slope of it, because the tangent line determines only one point on the curve, which is the point of tangency. Remember, to find the slope of a line, we need 2 points. To address this, we need a line that passes through 2 points on the curve. This line is called secant line. To illustrate this further, let's take a look on this illustration. Using the same function, let this function be f of x. Select a point on the curve. Make it as a point of tangency. Let the x-coordinate be x. Then the y will be the f of x. Then the coordinate of this point is x and f of x. Select another point on the curve. Let the distance from the first x-coordinate to the other coordinate, x-coordinate, be changed in x. Thus, the x-coordinate of the second point is x plus delta x. Then, the y will be f of x plus delta x. The coordinate of the second point is x plus delta x and f of x plus delta x. And the line passes through 2 points on the curve is the secant line. Given these details, we can now find the slope of a secant line using the fundamental concept of slope of a line. The slope of the secant line can be found as the ratio of change in x and change in y, or rise over run. Change in y is the difference between the y-coordinate of the second point and the first point, which is f of x plus delta x subtracted to f of x over change in x, which is the difference between the x-coordinate of the second point and the first point, which is x plus delta x subtracted to x. Simplify the denominator. X minus x is 0. Then the remaining term is delta x. On the top is the whole numerator. This is now the slope of the secant line. Our goal is to find the slope of a curve at a specific point on it, which is determined by the slope of the tangent line. What we have right now is the slope of a secant line. How can we get the slope of a tangent line using the slope of the secant line? Pause for a moment and think, how can we get the slope of a tangent line using the slope of the secant line? To visualize this, let's make it in GeoGebra. This is the same function we used a while ago, and this is the change in x, which is the distance between two x coordinates. Observe the change in x. What will happen to the secant line when change in x becomes smaller and smaller? Pause for a while and observe the graph. As you can see, when change in x becomes smaller and smaller, or when change in x approaches to 0, the secant line becomes the tangent line. Thus, when we get the limit of the slope of a secant line as change in x approaches 0, it becomes the slope of the tangent line. To continue this reasoning, remember that we said a while ago that the slope of a curve at a specific point is also the slope of the tangent line. Thus, the slope of a curve at a specific point, or the derivative of the function, can be found using this definition. dy over dx is one of the symbols to indicate the derivative of the function. Other symbols you may encounter are these. There you have it, the definition of derivative of a function. Next videos emphasize how to use the derivative definition to find the slope of a curve function. If you learned on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!